Okay, good day, grade 10. Now, today we are going to look at atom. And what is an atom? We need to understand that this is the smallest particle of an element. So here we must understand that your atom cannot be separated. An atom is the smallest, very smallest part. So you can't separate an atom. So an atom is actually it cannot be broken into smaller pieces. That's what an atom is. And we are going to just look on the models of of an atom. So now models, these were developed over years because you find that scientists knew that every matter is made up of small particles, but what is that smallest particle? And they were trying to know, how does it look like? What is inside an atom, and what does it do? What are its properties? Okay, so here we have got different models here. These were different models that we developed over time. So atomic model represent what the structure of an atom could look like based on what we know about how atoms behave, and it is necessarily a true picture of the exact structure of an atom. So we want to know how did these guys understand an atom. So you find from the Dalton model. Dalton model just believe that this is a sphere. It's actually a sphere, and a solid sphere. And in that solid sphere, he couldn't tell much of that sphere. But what he understood that the whole structure, they are actually identical. They are actually identical in those atoms. Then we move on to Thomson. Thomson model believed that in an atom, there are two charges. There are two charges. There is a positive charge and there are negative charges. But now the positive charge is surrounded by a pool or soup. Should I say a soup of of negative charge? So that's what we have. So we actually believe that around the positive charge, there are a lot of negative charge. So you have a good idea now, and those negative charges, you couldn't know what it is. Now we move on to the Rutherford model, and in this case now you believe that we have the core, the nucleus, and the nucleus is actually weighs more, and in that nucleus you believe that there is a positive charge there, and surrounded around it we have got electrons, but these electrons, they are just randomly scattered around around the nucleus. That's what he believed. Then we move on to the Bose model, and in this Bose model believe that these electrons, yes, we have a positive charge in the center, that is our nucleus, and that's constitute much of the mass, because the electron doesn't weigh much, but the nucleus is the one that have more mass there. Now, to see this, you believe that there are energy levels. So you believe that those electrons, they are not only just scattered everywhere, but they are pegged, or they are arranged in levels. So there are levels that are in those electron orbitals. So you believe that they are actually in certain sites, man. They are found in in levels, according to the energy levels. And what I'm going to explain here, I'm going to explain more now based on what we know now on the atom. Now these are the modules that I'll upload these notes, and you can also request the notes. There's no problem, we'll actually send to you. Then, but on the last year, James Chadwick now discovered the neutron. He believed that the mass of that nucleus, there is something else in that nucleus beside the protons that are positive charge. There is also neutrons. There are also neutrons on the in the nucleus. So now let's now look at, we're just gonna look at a calcium. Now, what you need to know, guys, that we have, this is what we call the nucleus. This is what we call the nucleus. And in our nucleus, what do we have? We have got protons. And what else do we have? We have got neutrons. Now, in this case now, but we also have energy levels around them. Now, these electrons, they are equal to to your protons. So your number of protons are equal to number of electrons. So that's why we find that these elements, these what you call these atoms, they are neutral. We call them what you call a neutral. So you can only start having an ion when an atom lose or gain an electron. That's when we can have an ion or a cation. Now, in this case, all the atoms they are neutral in general in our what called natural state. They are neutral, meaning to say protons are equal to electrons. Then in the nucleus, that's what we have. But in the nucleus now, we have protons and neutrons, and this give us what we call the mass, the atomic mass, the atomic mass. So here, atomic mass is actually your protons plus neutrons. So neutrons plus protons give us what we call the atomic mass, and we have got what we call atomic number. Atomic number is actually number of protons. Atomic number is number of protons. Atomic number is a number of protons. So here we must know that atomic, we're just gonna say number is your protons. So amount of protons, we are referring to it as what we call atomic number. And here, because these two are found in the nucleus, we can also see the word nucleon. Nucleon. So here, I don't know the spelling, but it's nucleon. Nucleon. Let me see here. It's nucleon. Yes, correct. So we have our nucleon number. So here you must know that this is the same as what we call as our atomic mass. And from there, what else do we need to know about atoms? We need to know that in the first shell, this one is a lower energy level. Is in the lower energy level. We call this as orbitals. Lower energy level. In the lower energy level, it can only be filled with 2 electrons. 2 electrons can only fill the first shell or first orbital. Then in the second energy level, it can be filled with 8 electrons. So you must always know that given the number of electrons, like in this case we know that there are 20 electrons, and what do we need to do? We need to first have our first orbital, our first shell energy level. We have got 2 electrons filling it. Then the second shell is filled with 8 electrons. Then the third shell again is filled with 8 electrons again. So but now we find that if we say 8 plus 8, we have 16, and plus 2, we have got what? We have got 18. We are left with now 2 electrons. And these 2 electrons are on the what you call outer shell. 2 electrons. So here is what we have. So because to make it what 20. So if we have to add this, we'll actually get 20. So which is your number of what you call electrons. So atomic mass, what do we know? We know that it's what you call a number of what you call protons plus neutrons. So in this case, we've got 20 plus 20. So you find that is 20 plus 20 giving us 40. So you find that the atomic mass of what you call the molar mass of calcium is actually 40. So that's what we must know. So because we are adding protons plus neutrons. Now, here is another thing again. Let's say they ask you that atomic, what is it? What can I say? What we have here? We have got neutrons, okay? We have got neutrons, we have got protons. Okay, it's fine. Then here, this is an electron configuration which we are going to look at as well at some stage. But here is just for you to understand what an atom is and what it's made of. Okay. Then we must know that the proton is the positive charge, the electron is the negative charge. Okay. Then it carries the positive, it carries the negative. Then let's see here what we refer to these outer electrons. These outer electrons, we call them valence electrons. Valence electrons. So valence electrons are outer electrons. Outer electrons. That's what we refer to a valence electron. Then the core electrons, we are referring to inner electrons. So you can say valence here. Valence electrons in this case, there are how many? There are 2 electrons. So if you have to be asked how many valence electrons, and these are the ones that are used in a reaction, isn't it? When in chemical bonding. So these are electrons that are used only in chemical bonding. So in chemical bonding, whatever type of chemical bonding, the electrons, valence electrons are the ones that are used. Then we've got what you call core electrons. So here, if we have to look at core electrons, how many are they? We are going to say they are actually 18 electrons. So they are 18 core electrons. They are 18 core electrons. Now, the other thing is, you must know that when calcium is a metal, and when it's reacting, how does it do? It loses electrons. It loses to obtain what you call a stable state, because a stable state must be the shell must be filled with 8 electrons. So in this case here, we are having 2 and we need more 6, but we can't do that. The calcium would rather lose 2 electrons to gain what called a stable state. Now when you say number of electrons for calcium, so calcium 2 plus, so 2 plus meaning to say it have lost 2 electrons, it will mean that it will have got how many electrons? 18 electrons. So 2 plus will be having 18 electrons. So now this is just a what you call another what you call, this is just for you for the notes that I will send. So you've got the first shell, the second shell, and the third shell, and you must know, remember, the first shell always filled with 2 electrons. The actually the following shells on the higher levels, they are filled with 8 electrons. Okay, then what else can we talk of? We can also talk of what is it? Isotopes. Let me just cover isotopes here. Isotopes, you must know that these isotopes, they have got what called same atomic number, which means same number of protons. So protons, they are equal. In that nucleus that we spoke about, in the nucleus, the atomic number is the same, meaning to say the number of protons are the same, but different atomic mass. Atomic mass, now remember, is actually protons and neutrons. In this case, we're saying number of neutrons is different in this case. That's why we are saying it's different in atomic mass. And we can get an example of what we call relative atomic mass. Now, what we have in the periodic table, those are relative atomic masses, because in cases like of chlorine, you have got isotopes, meaning to say here, if we have chlorine 35 or chlorine 37. So now when we have chlorine 35, we've got 18 neutrons, but here 37 have got 20 neutrons, but the rest is actually equal. The rest is actually equal. Number of protons, number of electrons is actually equal. Then in terms of abundance, naturally, chlorine 35 is 75%. Then chlorine 37 is 25% naturally. Now, when you have to calculate relative atomic mass, we calculate by saying 75% over 75 times 35, which is our what you call atomic mass, plus 25% times 37 to say, all right, 25% of that 27, then what we get here is what you call relative atomic mass. Relative atomic mass. I think this will understand more also when we are attempting questions on the on the materials. Okay, so until next time, guys, thank you so much. I hope you enjoyed the lesson. Until next time, thank you so much. All the best in your studies.